Hi, everybody. This is Mike Hanish, and I am presenting my final project, day late. Unfortunately, I'm sorry, work was terrible. I actually do work at Walmart, and that is what my project is about. And starting the introduction of the statement, what I wanted to find out is whether extreme temperatures, atmospheric temperatures like weather, for instance, and holidays, do they increase sales? I made when I started this project, I assumed that they would because like extreme cold days. Oh, I thought, well, uh, there go just a jump in the sales of salt for driveways and snow shovels and things like that. Hot and extreme hot days. I thought there would be a significant increase in sales of like sunscreen and items like that. And I thought it was a foregone conclusion that holidays would have a statistically significant impact on sales, causing a demand, oh, excuse me, a demand spike. Let's see how it turned out. The research questions I had were: do extreme temperatures and temperature directly affect the weather sales at Walmart? And do holidays affect the weather sales at Walmart? My hypotheses were null hypotheses for the temperature. Null hypotheses: temperature has no effect on weekly sales. The alternative hypotheses: temperature does have an effect on weekly sales. And for holidays, the null hypothesis is holidays have an effect on weekly sales, and the alternative hypothesis is holidays do not have an effect on sales. The data set I use, I uploaded from Kaggle. I'm not sure how you pronounce it, but it was a pretty large one. It had 6,435 observations, and the variables we're going to look at were weekly temperature, weekly sales, and holiday flag. Both of those, the first two are continuous temperature ranges and weekly sale ranges, while holiday flag is 0 or 1. It's categorical. It's either a holiday 0 or not a holiday 0 or a holiday 1. And these are from 45 Walmart locations. 45 out of over 10,000 worldwide. That's really actually smaller than I thought. A pretty small sample size. Okay, let's see the data preparation and methodology I use for data preparation. I use the standard cleaning blank cells, eliminating blank cells, but I kept outliers in this for this project because I was looking for extreme hot or extreme cold temperatures to see how they would affect sales. Made sure holiday flag was categorical, and I used correct formatting for dates, money, and temperature. The methodology I used Excel's data analysis tool, and the whole time, and I also used Excel to make graphics. Look at some descriptive statistics for temperature. The mean is 60.66, which means from our small sample size of about 45 stores, they're in a moderately warm climate. I would say probably in the American South. Uh, and also, with the median, we have 62.67. That means there are going to be more warmer stores in the warmer climate because the median is higher than the mean. The mode, 50.43, suggests that colder temperatures occur often. So there's like cold snaps. The standard deviation is 18.44, which is large standard deviation, which indicates large variation, um, implying that there is a great wide range of temperature readings. And the range is 102.2, which is quite large. Let's see. And the regression analysis for the weekly sales and temperatures. And what we see from the scatter plot on the left is there wasn't a lot of correlation between temperatures, not as much as I thought. You can see that the temperature maxes out around a little over 100, and the lowest, the extreme lowest, there's only one that gets below zero. So that shows us that these states are probably in the American South. And if you look at the outliers above, the extreme sales are in a temperature range between 20 and about 62 or 64 degrees. That's something that I wasn't expecting at all. So if we look at the goodness of fit statistics, our multiple R shows very weak correlation. R square tells us temperature fluctuates only 0.4% of the variation. 0.4 of 1%, that's not very much. Standard error was high, showing low predictive quality. The coefficients table, for every degree rise in temperature, sales reduce by 1,952.4 or $1,952.42. And that's not much. When you look at 1.5 million or sometimes 1.6 million per sales per week for some of these stores. So that's hardly anything at all. If you look at the holiday flag analysis, the graph on the left, the Gerline fit plot, shows there is a positive correlation, but not nearly as much as I thought, which makes me wonder because when I work at Walmart during the holidays, the sales are incredible. I mean, the amount of people in the stores, there is a huge increase, and I feel that I've done something wrong in this project. But let's take a look at the goodness of fit statistics. The multiple R tells us there's a weak correlation between weekly sales and holidays, but there is a correlation. R square at 0.42% of variation in sales is attributable to holidays. ANOVA shows a statistical significance, but not really practically significant. That's just a mystery to me. I don't understand that. The coefficients table says that sales increased during holidays by $143,503. Like I said, this is not a whole lot compared to $1.6 million in sales, but there is an increase and it is predictable. It's like a seasonal trend that will return all the time, every year. It's cyclical. And the conclusion, the test performed on the variables temperature and weekly sales showed almost no correlation. As a result, there is a failure to reject the null hypothesis that temperature has no effect on weekly sales. Regression statistics show extremely low values for multiple R, adjusted R. Additional correlation coefficients show a weak linear relationship. The scatter plot presents this conclusion visually. It is evident that from the plot that the highest sales weeks are infrequent and occur within a moderate temperature range. A Walmart store manager does not need to stock additional items because of extreme temperature forecasts. But for the temperatures performed for the variables holiday flag and weekly sales, showed a weak positive correlation between the two variables. Holidays do increase sales at Walmart stores, and management should prepare for increased customer demand, stocking additional items. Although the increased demand is not a spike, in the strictest sense, avoiding stockouts on holidays will help Walmart to maintain goodwill with customers. I agree with that. I think that some of the holidays here included are not the major ones. I don't know if they're including President's Day. I don't know if they included Arbor Day or some of the or something like that, which don't increase sales. But I can tell you from experience that Thanksgiving, Christmas, Valentine's Day to an extent, and Fourth of July. I mean, and weekends like Labor Day and like that, the sales, I mean, it skyrockets. And I'm not sure what happened in this study. Well, maybe we'll try it again sometime. Thank you for listening.